So I want to give you some more examples of the pH calculations to give you some more practice. And so I'm going to be working some problems off of the Race to the Finish review sheet that we have already done parts 1 and 2 on, and 3 and 4. So the problems I'm going to be working from here are on part 5, the pH and POH calculations. And again, there's 6 of these problems, and I'm going to be working through these for some guided practice for those of you that need some more examples of how to manipulate the pH and POH calculations. So remember our formulas that we learned on Friday. The first one is the hydrogen ion concentration times the hydroxide ion concentration is equal to 1 times 10 to the negative 14. The next two look very similar, but pay very close attention. pH and POH can be calculated by taking the negative log of the H for the pH and the negative log of the OH for the POH. And then finally, the fourth formula says that the pH plus the POH, when you add them together, equals to 14. Let me clarify about sig figs real quickly with the formulas. Remember, anytime a number is in a formula, it technically has unlimited sig figs. So this is 14.000 to infinity, if you will. And here with this one, this is 1.00000. So it has unlimited sig figs. So do not let these numbers determine your sig figs in your answer. Okay, so for number 1, it says determine the pH of a 0.0034 molar hydrogen ion solution. So the concentration of hydrogen ions is what they're giving you. This is H+. Remember, the square brackets always indicate that it's concentration in molarity, and we're looking for pH. So we need to use formula 2. Always write your formula down so it's very clear what you're plugging into. pH is negative log of H. This will also help you remember your formulas the more you write them down, and you'll be less likely to make careless mistakes later on. So we're going to plug in here to the hydrogen ion concentration. So pH is equal to negative log of 0.0034. Now, I do want to remind each of you that pH is a unitless number, so the pH scale does not have a unit. Unlike if you're solving for something in square brackets, the brackets will have a unit if you're solving for a bracketed ion. But pH and POH do not have a unit. So when you plug it in your calculator, make sure that you use your negation sign. So the plus minus key, if you will, you say negative and log, and then you're going to plug in the concentration that you were given, 0.0034. So we're going to round this to 2 significant figures because leading zeros don't count. So we're going to say 2.5. 2.5 is your pH. Now, this question did not actually ask you this, but on the test you're going to have to be able to explain or identify. So if you're asked if it's acidic or basic, you want to remember that you'll want to look at your pH. So the pH here is 2.5. Since it's less than 7, you would say that this is an acid. It's an acidic solution. All right, for number 2, determine the POH. But they've given you the hydrogen ion concentration. So we do not have one formula that allows us to solve for the POH here, but we can use a combination of formulas. So since we have the hydrogen ion concentration, if we take the negative log of it, we will find the pH. And then once you get the pH, since they're wanting us to find POH, we know pH plus POH equals 14. So we're going to use formula 2 and formula 4. So I'm going to first plug in pH equals negative log of H. So that's going to be negative log of 0.0034. And if you plug that in, it's actually what we just plugged in up here, if you pay attention to that. So up here we have the pH is 2.5. So if we want to now find the POH is equal to 14 minus the pH. Now I just took this formula and rearranged it. 14 minus the pH. So 14 minus 2.5. And since when we add and subtract, we go with least decimal places, this has one decimal place. And remember this 14, because it's part of the formula, has unlimited decimal places. So we say 14 minus 2.5, and we're going to get a POH equal to 11.5. So that will be your final answer on number 2. All right. Number 3 says determine the pH of a 4.3 times 10 to the negative 4 molar hydroxide ion solution. Y'all try this one on your own. Pause the video if you want to, and then restart it when you're finished. Try this one on your own. We're going to need to use 2 formulas here. I'm going to go ahead and finish explaining it. So since we are given the hydroxide ion concentration, we're going to take the negative log of that and get the POH, and then we'll subtract from 14 to get the pH. So POH equals negative log of the hydroxide ion concentration, and so negative log of the 4.3 times 10 to the negative 4, and that's going to give us a POH equal to 3.4. Now again, we just found the POH, and the question wants us to find the pH. So if we have the POH and we want to find the pH, we're going to use formula 4, where you see pH plus the POH always adds up to 14. So the pH is equal to 14 minus the POH. So 14 minus 3.4, and that's going to give me for my pH 10.6. So that means this is a basic solution because we just found the pH and it's greater than 7. All right, formula or question number 4. Here we're given the pH and we want to determine the hydrogen ion concentration. Now, hydrogen ion concentration in our formula looks like this. Hydrogen ion, if the brackets were around it, it's a concentration. So for this one, we are going to use the pH formula, number 2. pH is negative log of H. Now this is one that we're going to have to end up taking the anti-log. So I'm going to try to go slowly through this and explain it very, very slowly. So remember, always write down your formula. pH is equal to negative log of getting ahead of myself, of the hydrogen ion concentration. Okay? So that's our formula. Now here they gave us pH. So we're plugging in right here for pH. This plugs in here. 2.98 equals negative log of hydrogen ion concentration. Now, the first thing you have to do when you're trying to isolate your variable here, the x, is you got to remember to divide both sides by -1 because we got to move the negative over to this side. So you divide by -1, you divide by -1. So that makes this number negative and makes this side positive. All right. So I'm going to come over here and finish that. So what that gave me from this portion is negative 2.98 equals the log of hydrogen ion, or the log of x. Now, in order to move the log over, you have to use the anti-log. Now, on our calculator, if you find your log button, you will notice that the second function of that is 10 to the x. So if you hit second log, that's called the anti-log. So we're going to hit second log, and when you hit second log, you should notice that a 10 to the x pops up, or a 10 to the maybe the carrot top pops up. Okay. Now, what we're going to do is take the anti-log 10 to the x, and what that does is it gets rid of log on this side, and it isolates your hydrogen ion concentration. So the anti-log of a negative 2.98 is what we need to plug into our calculator. So let me again show y'all how to do that. So for this, you're going to go second log of a negative, it's your negation sign, 2.98 equals. Now,